maybe you grab your neighbor for the show, because I do recommend look to get as much people to get involved in this interview. Grab everybody around you and gather along for this conversation. It's going to be a very interesting one. Today's guest is Andy Tzadinakis. I don't know if I said that right. Again, I kind of asked this man before, so hopefully I didn't butcher it. So Andy is a post-baccalaureate research scholar at the California Institute of Technology, Caltech, working as astrophysicist researcher. So his current research focuses on the physical process of stars going supernova using telescopes around the world. So Andy is particularly very passionate about using data science, software development, and innovative data visualization techniques for further understanding of the universe. And again, there is more information and part of this work, and you become part of Andy's journey here if you're going to go to Instagram or YouTube. So Instagram is Andy Zastro, or YouTube Andy Tzan. Of course, those links will be included in the show notes. So go and ask him questions if we missed something here in that conversation about going supernova here. So look, Andy, I really appreciate you coming today on the show. First of all, love the enthusiasm, love the energy, what's happening here. And want to dive deep into the questions. I want to ask you, how did you came about being part of this astrophysics researcher? Where does your personal journey started? Just give a little bit of background and what you're currently working on also.
Yeah, sure. Well, first of all, it's a great pleasure to be on the show again. So my journey of how I started with astronomy, well, it's sort of unconventional. So I started doing photography when I was really young. So I had a family relative, and he just, handed me a camera. And it was always just a very innocent process of just, taking pictures of just random things. And then eventually I sort of became curious about like, whoa, it would be interesting to take a picture of, like the night sky, or like, take a picture of the moon or the stars. And at the time, I sort of, it was like that weird phase of the internet where like not everyone had internet. So at that point in my life, I was around like 13 years old. I didn't have internet still. So I didn't even know what astrophotography was, or like that there was a huge community. So I guess I was doing astrophotography before I knew that I was doing astrophotography. So it started from there. And then, I sort of started to realize, well, hold on, like I want a telescope, because like I started to realize that like you need a bigger like lens to like collect more light. So eventually, I went and got myself a telescope. And then before I knew it, I was like, well, hold on, like I think that what I really like is astronomy. It's not the photography, even though I was really passionate about the photography. So yeah, it started from there. I was doing astrophotography until like age 21. But that was sort of my side hobby. But then I started to realize I was a lot more passionate about like the sort of the technical details of, of astronomy and astrophysics. So, it started, such an early thought, and then, it became such a thing. So, when I graduated high school, I was like, well, damn, like I could make this into a career. Like it was crazy to even like meet people. So when I was 18, I went for the first time to, actually, no, I was like 15. I went to an observatory for the first time. And, this was like a professional, like 2-meter telescope, class telescope. I met the staff astronomers who were there, and they were like, yeah, like we get paid to do this kind of stuff. I'm like, well, hold on a second. I was like, I need to get into this business because this is awesome. Like, like you get to study something that is just so far and just like so beyond our reach. So yeah, I was sold. I was like, I'm gonna do this. At the time I was living in Greece. And I decided to move back to the United States and go to college and, pursue astronomy and astrophysics.
Beautiful. So that's a kind of, long story short, right? Probably, I don't know how many years we condensed in here in that, 2 minute part here, but look, I'm sure there's many more to that, but, what would you say for anybody who's looking to do something with what you do, again, through the journey that you had so far, again, and where you are currently? What would you recommend for the future astrophysicist, like when it comes to making that decision for a full-time career?
That's a great question. I've been thinking a lot about this because I think that what we typically used to do, well, I guess I should say, how do we typically think about scientists, right? If we think about, we go way back and we think about how scientists were classically trained, it was only sort of through the privilege of wealth, for example, that people could really study, or if you were a philosopher, that you could really afford to go to university, and if you were good at math or physics. And I'm going to tell you something. I honestly, personally, in high school was not good at math or in physics. So it's always funny to hear like these stories of like I was a genius in math, so that's why I decided to go into science. And I think that specifically astronomy and astrophysics is becoming a very interdisciplinary study, meaning that you don't only need to be a good mathematician or a good physicist. You could have a really good idea about computers. You can have a really good idea about design. You can have a really good idea of so many skills and components that go into it. So it's not that like if you meet someone who's an astrophysicist or an astronomer, automatically is like this guy is like this person is a genius in their field, a genius in in physics or in math. It captures a broad range of skills. So to get to my point, I think that what I would recommend to someone who wants to start on this journey, sort of just follow whatever your passion is. Let's say you're interested in space, right? Like for me, like it was photography. And I didn't know that photography was going to lead me into astronomy and astrophysics, right? Like you start out somewhere and you don't know where that journey is going to take you. You have a direction of going, let's say, to the supermarket, but you don't know like all the little stores that you'll hit in between, right? And for some people, like that could really mean anything. That can mean reading science fiction, looking at seeing movies about space. Whatever it is that sort of gets you excited, go in that direction. And if it's sort of meant to be, and if it's sort of meant for you to have this innate passion within you to study, to study astronomy, then it'll happen. I always say, like, don't pressure it. Let life happen, and it will sort of come to you naturally. Yeah.
Got it.
Yeah,
Got it.
long answer.
Yeah, no, that's perfectly fine. But just know that there's a supermarket at the end that you're looking to go, right?
Absolutely, absolutely, and right.
Yeah.
Right. I should say that too. I mean, like, of course, when you reach a point where, let's say, university, I was talking about that in terms of before you even get to a university, or you have the opportunity to officially start studying. But when you do get to, let's say, a high school or college, you do want to set a goal, right? It is about really being persistent about something. I mean, it's, of course, not an easy thing to do. Science is very notoriously known for being a really difficult subject to studying in all levels. And alongside with that, our educational system globally is not designed to, train scientists to the maximum, right? It's still a system where it's like, if you're not the best at it, you're most likely not going to do it. It's very discouraging. So you really need to be committed, and you have to be ready with have that goal. And like, as we said, right, like, I'm going to make it to the supermarket. I'm going to become this, whatever it takes. And we all start out, unfortunately, not with the same opportunities. So that's another really big difficulty in society. Not all of us have the same privileges to go to college and etc. So for each person, it's a really long journey. But if there is persistence, and if there is a little bit of cosmic luck, I think that it's definitely an achievable career.
Definitely, for sure. And I definitely agree that not everybody are exposed again to, as you mentioned, because before, if you were wealthy, you probably had a bigger chance to become more educated than the poor people. And it's still happening the same, probably to some, a certain degree, because probably it's not going to be the best example, but probably a year ago I seen these, I think there's 3 or 4 kids from Africa, and they were creating these movies with a little bit of a CGI kind of, and these science fiction movies, and the
Yeah.
way they look. I mean, the way I checked this kind of short movie, probably 5 minutes movie. You can probably guys also find that on YouTube or internet. It was just insane. I mean, and they're
Yeah.
working with this kind of broken computer, the wires
Yeah.
hanging out, and it's
Yeah.
it's insane what's possible. Because pretty really, with the equipment and with the education that probably some people have access to, these
Yeah.
people, these guys probably would crush. They would probably will become the next Steven Spielberg or something like that.
Yeah. Yeah.
So,
Yeah.
but
Yeah.
they don't have access again to the
Access,
resources,
right?
which is
This
you
is
could, yeah.
yeah, this is a really big topic. I mean, specifically in the field of science. I mean, like, especially when we're talking about science communication, right? We are we are at a point where, access is becoming a lot easier, but it doesn't mean it's also creating this illusion that, for people who are living in wealthy countries are able to access this, right? Like, like you and I, maybe it's a given that we have an internet connection, but for many countries, internet might not be stable. There might be certain restrictions on what kind of education you can access, which is another big thing. There's all these sort of inequalities in society about education that I think that science communicators are actively trying to dismantle, or actively trying to, sort of give people that momentum that, like, all of this information that you're trying to learn, is accessible, but people don't know where to look, right? People don't know where to start from. So
Exactly.
yeah, it's an interesting challenge.
It is, as I said in a previous conversation that I just had before we started, asking the right questions is the problem. How do you find how to ask the right
Yeah,
questions? Because the answers are there, and a lot of people are struggling because they're probably focused on themselves a lot, kind of having that internal conversation
yeah,
instead of saying, just opening up their minds and saying what's out there available and starting to search for these answers. So asking effective questions in your life or business or in studies in general, just
yeah,
opening that mind a little bit more. So talking about opening the mind, like, do you follow any certain, like, personally, do you have a role models or some people that
yeah,
follow, and
yeah.
or there's some YouTube videos that inspire you and kind of, that make you go back to the studies or the work that you do?
Yeah, yeah, yeah. Actually, I was just thinking about, like, yes. So it is. I just want to go back one point that you
Sure.
said, that, right, asking the right questions, but it's also finding the right role models. And I think that
Mhm.
society in a whole, and especially again in the sciences, um, we're still lacking. Students are still lacking the role models, right? Like, we're just entering this era now where we could start seeing some role models that are just not your typical, like, white male scientist, right? Like, because that's what sort of the world knows. So, for women, for example, right? Like, we're having, like, the first women in space, or, all these powerful. So, for example, I've been doing research for the past almost going into 6 years now, and all of my mentors have been females. So, it's always incredible because, like, it's such an inspiration because, like, if you're a young little girl and, like, you want to study astrophysics, and all you see is, like, these white male scientists, then it becomes a problem because you're like, you can't relate. You can't say, I want to become that, because you usually relate to something that looks like you and is like you. So I think that it's important that we also expand this bubble of, like, who can be your role models in society, and give the platform of science communication to all people, right? People of color, females, all sort of communities that we can, to really get students, all kinds of students excited, not only students who are wealthy. Yes. So to your second question, science communicators that I've been currently following, or sort of role models. Well, I think that I definitely grew up. It's sort of in the age of, your typical science communicators on YouTube. So Veritasium, for example, huge, huge inspiration on that. 60 symbols. So yeah, I think I was part of that generation that just loved watching all these amazing science communicators on YouTube. And I want to say, were a huge part of my motivation to, like, say, like, yeah, I could do this, I could do this. And of course, legendary Carl Sagan,
Yeah.
huge fan of Carl Sagan's work. So yeah, these were sort of my role models sort of growing up. But I think that sort of, at the point of where I'm at right now, I think that the word role models is becoming a little more intricate, meaning that it doesn't need to be someone of fame, right? Like my role model is like my mentor, my research advisors, because these are people who are leading example in the field. It's a lot more like day to day how you see them making impacts in their own communities. So I often tell students to don't only look for the people who are in the lights of fame, but look for the people who are in your everyday life. You know, that could be your parents, that could be your cousins, whoever it is. Try to look more locally too. I think that often goes underseen a little bit.
So besides that, having the role models, in front of you who you can have these conversations or via YouTube, like any of the books that you recommend that you read, maybe kind of science fiction or different, not related to astrophysics or astronomy community. Anything you recommend?
Yeah. I think let's see. Favorite good book for just science communication. I'm such a Carl Sagan sucker. I mean,
Go
like,
ahead.
Pale Blue Dot is like just such a legendary book. It's such a good read. It really and it's not like it's exquisitely only about astronomy. Well, it is, but Carl Sagan has this really cool ability to just give you one of the most important essences about astronomy, scale, right? Like when we think about like astronomy, it really what the most mind-blowing thing about it is just the scale of things, right? Like the scale of the solar system, the scale of the Earth, the universe. And Carl Sagan just has this insanely good talent of just writing and just like immersing the reader into this sort of cosmic perspective that like whoa, like like we do live on this tiny little dot on Earth, and compared to the universe we're just like this tiny little speck. So if you haven't read it, I always think that Pale Blue Dot is such an amazing place to start from.
Awesome. So that's a great recommendation. Kind of presenting a difficult, probably most of the time difficult to understand science language in a kind of poetic manner.
Absolutely. Yeah.
So it's really great read.
Yeah.
So where does your personal passion? I mean, how did you came across? You mentioned data science, software development. So where does that kind of passion come from? How did you came across that, and how have you decided that this is kind of the path that you want to follow?
Yeah, so I guess it's sort of the path of research. So when
Yeah.
I came back to the United States, I first started at a community college. Now, I don't know in Europe or other parts of the world if they have that, but essentially, a community college here in the United States is you only do the first 2 years of your degree as an undergraduate student, and you get an associate's degree. So I started a small community college here in New York City. And at the time, when I went into university, when I went to the community college, uh, I knew that I wanted to become an astronomer. But as we said before, it's asking the right questions and not knowing where to start from. So for the first 2 years, I was, studying math and science, and was trying to be involved, but I wasn't yet doing anything until I met an astronomer who was on the campus. So she took me under her wing. We officially started doing research. She was an astronomer, and we started doing research. And at the time, I was working in a field known as galactic archaeology. So the essence of galactic archaeology is trying to understand how the Milky Way galaxy came to be. And it's sort of like being an archaeologist, but you're being an archaeologist for our own galaxy, the Milky Way. So, one of the amazing things about galactic archaeology is that, the solar system, the Earth and the solar system are within the Milky Way. And there's one good thing and there's one bad thing about that. The bad thing about that is that when we look at pictures of space, for example, we could see other galaxies, right, in the universe. And so we know what other galaxies look like from an external perspective. But the trick is when we ask, well, what does the Milky Way look like from an external perspective? Since we're in the Milky Way galaxy, right? You could see the banded structure, if you have a really clear sky, but we don't know what the galaxy looks like from the outside, right? How we would see other galaxies. And the analogy I like to make is like or I've heard this somewhere, is we don't have a long selfie stick to see what the Milky Way would look like. So a galactic archaeologist is trying to use information observed from stars and how they move and what is their chemistry like to basically rewind the tape and figuring out, well, how did our galaxy come to be? What does it look like? And what can we learn about that? And that could shed light onto how other galaxies form. Because if we understand how our galaxy forms, then we can maybe take one step later and say, well, if this is how our galaxy formed, then maybe this is how most other galaxies like the Milky Way formed.
And can I ask you why that particular research would be important?
Right. So so the question is, well, how, right. So yes, it is a little trick. So you have the Earth and you have the solar system, right? So on a scale of the solar system, it really doesn't, I guess it's really not that big of a question, because you're like, well, that might not be directly related to, like how the Earth was formed, for example. But if you didn't have our galaxy, you wouldn't have the sun, and then you wouldn't have the Earth. So it's sort of a chain of understanding, a sequence of things, right? Also, understanding how galaxies form tell us a lot about how the universe came to be, because it turns out to be that most of the, well, I mean, all of the mass in the universe is really, well, the observable mass, what we call the baryonic mass, is in galaxies. So it's a really crucial component when it comes to understanding the very formation of the universe is, well, how do galaxies form? Because these massive islands of, stars, what we call galaxies, is a very crucial part of our universe. And so if we know how galaxies form in general, we can learn a lot about how the universe came to be, and then you could start squeezing in your questions and saying, well, that's how stars are formed, and that's how planets are formed. So it all funnels down, but you have to ask the bigger questions to sometimes come to
and
a
what type of technology or what type of research are we currently using to find these type of answers?
That's right. That's a good question. So in astronomy and astrophysics, there's sort of two broad umbrellas of how people go about this. The one is the conventional theoretical approach. So that is through math and simulations and using all sorts of physics to sort of understand what would be the theoretical foundation of it. And then you have people like me who are involved in the observations. So this is using basically telescopes all around the world in all sorts of wavelengths. We go from radio to X-ray to optical light, and we study the properties of things in space. So that could be a star, that could be a galaxy, that could be a nebula, it could be anything. And then using that light, we could really study a lot of things. We can know how far things are away from us, how fast they're moving away from us, how are they moving, what is their chemistry, because it turns out that what the chemistry of something in space could tell us a lot about what it is, and what are some of the physical mechanisms happening. So observers are sort of limited to that sort of thing, using mainly telescopes and experiments here on the ground. So you can have things like CERN, like particle accelerators, to sort of understand more. But for astronomy, it's mainly through telescopes and data.
And how far away are we from uncovering this discovery of how the galaxies were created?
Yeah. So right now we're at a golden age. I think this is probably the best time to get into this. And the reason is because we are at the brink of a sort of golden age of data. And so this is sort of how I got involved in sort of this whole data business. So right now, the Europeans have this space telescope, which is called Gaia. And Gaia is able to basically resolve to a very, very high precision the position of stars and how stars are moving, using this technique of what we call a parallax. And essentially we have on the ground and in space all these telescopes that are surveying the night sky. We're taking hundreds and hundreds of thousands of pictures and what we call a spectrum. So that's basically, dispersing the light into its components and studying the chemistry. And that could tell us a lot about how fast they're moving and what's their chemistry like. So within the last, I would say, decade and moving forward, this data, first of all, is public. So after this meeting, for example, you can go and literally download this data and make your own discoveries, if you know what you're doing. So that's a huge breakthrough. But second of all, we're reaching a point in astronomy where we're starting to get close to the industrial level scale of data, meaning that what Facebook and maybe Google are producing in terms of data, where astronomy is starting to approach that level. So
Wow.
that blows, when you think about it a little bit, you're like, wow, like that's a lot of information. And when you think about like what big industries could do, like let's say advertisements, right? And all this insane research that they do on that level, we're reaching that now in astronomy. And so this is probably the best time to get into this because this data is coming as we speak. Like, I mean, like literally within the next 10 years, like we're going to have so much data and so much information about the universe that we need people who are not only astrophysicists, but we need people who are data scientists because it's becoming also a data problem. So it's a great time to get started with this in these days.
For sure. So it's great to know again that astronomy community. I mean, when you mention about the amount of data that they have, and again, I love the fact that instead of using that data to, if we can call it, spy on people and to create ads and track people and the way they live their lives, so we can sell more products or services to them. We're actually spying on nebulas and stars to actually discover what's going to happen, with the galaxies and the way they've been created. So a lot of people. I do want to ask you a question. Do you think there will be any benefits of us again having a James Webb Telescope? A lot of people talked about that. And it's going to be almost going to the point of where we can look at the point of Big Bang happening. So is that going to add any value to astronomy community when it's going to come to finding out how the galaxy has been created also?
Yeah. So the James Webb Space Telescope, first of all, is going to be a breakthrough because you look at just the legacy of what the Hubble Space Telescope has done for humanity. And even before I go into the astrophysics, I always like to say, let's take a step back. Look at how much of an impact the Hubble Space Telescope has had on society, right? Like every picture that you basically see on, I don't know, like here in New York, sometimes like if you take the subway, you'll see like these companies taking pictures from the Hubble Space Telescope and putting some text in the background. And when you really think about that, that's like taking a cosmic perspective and bringing it into society. And really, like when we look at the pictures that Hubble has taken, it's breathtaking. It has inspired so many of us to want to do astronomy and learn about astronomy. So the James Webb Space Telescope is going to be it's going to be this generation's Hubble Space Telescope and even more. So first of all, it's just an incredible mechanism to just inspire people to want to study astronomy. I think that when countries come together to do something cool in space, whether that's, launch a Falcon 9, go to the International Space Station, or just have something in space, people would just get motivated. People get pumped about space. So I'm always a huge advocate of that. In terms of scientific value that what we can learn from James Webb is going to uncover a lot of things. And right, so one of them is going to be studying really distant galaxies because it's mainly in the infrared. So we will be able to see, one of the earliest galaxies. This is not sort of my expertise, so I don't know exactly what the numbers are, but one of the amazing things that James Webb is going to be able to do, so I have a lot of friends who are working in this field of research, is looking for signatures of life on other planets with James Webb. So James Webb is going to have this incredible precision to tell us if there are perhaps any signatures of life on other planets. So it blows my mind that in our lifetime, we might get some understanding of if there is life on other planets using James Webb. And the way this is done is that how we understand life here on Earth, basically we have what we call biomarkers or biosignatures. And so if for example, you were an external observer and looking here on Earth, and you were to study the chemistry of that light coming from Earth, you would notice that there's some chemical signatures in that light that correspond to life that we humans emit and plants emit. And so with James Webb, it's going to be possible to possibly detect these on other planets. So this is going to be one of the biggest breakthroughs that James Webb is going to be able to do, and of course all other areas of astrophysics.
Yeah, so we kind of probably have the list already on NASA websites, because I think what you mean again is about having those exoplanets or potential habitable planets that we can live ourselves. And again, there's a lot of those already. As far as I see myself, I think we're talking about thousands of potential habitable planets. But the question is, how we're going to travel there, right? It's kind of the technology. We don't have the technology to go to these places.
Yeah. But I think it's interesting to study it. I mean, of course, that's the later problem. Well, if we find a planet that's suitable for life, right? It's how are we going to get there? But I guess this is the first step in that direction to ask, well, is there a place where it is suitable for life, like how we, what we expect here on Earth would be possible somewhere else. So, that's going to be the first thing. And then the other question is also, we have to create sort of a census. We have to know, basically, you wouldn't expect that a planet would specifically look like Earth, or would have specifically the conditions of what we have here on Earth. So what most likely is going to happen in the field is that we're going to have to create what we call a census, or a map of all of these planets that might be like Earth. I don't know if we're going to find something just like Earth or just like the chemistry of Earth, but it's going to be really exciting to uncover all these just sort of different things that we can learn about these planets in terms of chemistry, and all sorts of characteristics that we can learn using these telescopes.
Well, at least finding something closer that the Mars has to offer, would be good.
Yeah. Well, I think that Mars right now is not a bad idea. I think that if the world had just a little bit more interest in, if the space agencies were sort of a little more dedicated on collaborating, I think that it would happen faster. I think that Mars is a very approachable target for us to perhaps send humans. Well, not only send humans, but also inhabit Mars within the next, I don't know, like, I'm optimistic, so I'll say like 20, 30 years. I don't know, some of these official people are like, yeah, we could do it in 10 years. I'm like, realistically, probably not.
All good. It's good. It's to keep the optimistic spirit going. But again, the facts, because again, you're more of the kind of data-driven person, and okay, let's look at the data and let's see how much we can extract from there. So So just looking again at the facts, because again, that there are a lot of possibilities that we cannot be alone here. Again, it's either in this universe or in other universe, but because the extraterrestrial life forms could be that far away. And I'm sure, again, you living a little bit, as I mentioned, you stayed again in university and worked in there and being part of California. I'm sure there's a lot of people who having these kind of, maybe cult is a strong word, but just having groups of people, meetings and talking about UFOs. California is probably one of the big states. I know there's a lot of these states in the US where they talk about, a lot of kind of UFO activities happening. Look, there's a lot of those stories. Again, there's not enough data to prove that those stories are real or not. But from your personal view, again, and having these observations of supernova, and of course we have to talk about that, like, what do you think about just the chance of something else being out there, a little bit more advanced, not bacteria-like, but advanced form, being so far away that they're not able to reach us? Is it possible?
Yeah. So, when we talked a little bit about Carl Sagan's book on Pale Blue Dot, and we talked about scales, one thing that you'll realize when you first start studying astronomy is that the universe is really, really big. And I made a post the other day about on my Instagram about the number of stars that are in the universe. And there's this classic example of that. If you counted every grain of sand on a beach, on every beach on Earth, there still wouldn't be enough of grains of sand to count the number of stars. That's first of all mind blowing. So you really have to think how big the universe is. So that's one. Given that, it becomes so difficult for you to imagine that there is some extraterrestrial civilization that traveled from we don't know how far to make it to Earth and to come to, I don't know, like Nevada in the US and show up at some random village that you probably have never heard of, and somehow it makes it to the internet. Just the statistical probability of it, even looking at it from the most mathematical perspective, is basically zero. So when you really think about it like that, it's like, well, like the chances of them, let's say like some extraterrestrial life coming to Earth and then showing up at some very small state, which happens to always be in the United States, which I don't understand why that is. We never
Always in the
hear,
movies. Always in the
yeah,
movies.
we never hear,
They're going to meet the U.S. president always. It's
we
not the
never
president.
Yeah. Like I grew up like in freaking like a small island, well, pretty big island in Greece. And I never heard about UFO sightings. I mean, sure, you could hear tales of people like I saw something in the sky and I never knew what it was. So yeah, I'm a skeptic. I'm just a skeptic. Of course, could it be that there's something visiting our solar system that we don't know? Well, these are sort of the unknown unknowns. We cannot know what we don't know. So sure, it could be a probability, but it's also very, very, very infinitely small probability. What could be happening instead is that the universe is maybe full of life, but because the scale of the universe is so big, it almost becomes impossible to it's sort of what we call the Fermi paradox, where the universe is so big, and so basically it makes it look like there's no life anywhere because just the distances and the scales are so big. And then you also have the effect of basically the speed of light, right? I can't know if, for example, I can't know, let's say for a star that's like 100 light years away, if there's life on it now, because the light that came from that star 100 years ago is 100 years old. So whatever we're looking at in astronomy is basically, we're looking back in time. We're not looking at the presence. We're looking in the distant future. So, and every person, well, I shouldn't say person, every point in the universe has that same effect. So if some star 100 light years from Earth is looking at Earth, they're basically looking at 100 years ago what Earth would be like. So this would be sort of even before we had internet, which blows my mind. So yeah, I think that it really is a really big challenge of how exactly are we going to find extraterrestrial life in the next, I don't know what the goal is, but it's just moving forward into this field of astrobiology. It is a really big challenge of how are we going to know where life is? I mean, we don't know what shape or form it's going to be in. We don't know if it's going to be a pulse of light. I'm sure you know about SETI looking in the radio frequency, but who says that some other extraterrestrial civilization knows what radio waves are? They might have only invented the laser, for example. So they might be sending us little beeps of light, for example, and we might be missing that. They might be doing it in an X-ray. They might be doing it in all sorts of forms that we might not even know. So I think that one of the most promising things that could be done in the field is to start thinking broadly about how it is possible. So for example, now there's a lot of researchers who are working on sort of the optical signatures. So meaning that if you look at a star for a really long time and you notice something weird that's happening with its light, then maybe you could say, well, wait, there's something strange happening here. And so some researchers are thinking that this is a possible avenue to sort of find extraterrestrial intelligent life in the universe.
So you're talking just observing during observations on stars.
Yeah. So a really recent example is for this star called Tabby star. I don't know if you've heard about this. So it was discovered by the Kepler Space Telescope in 2013, I believe, 2013, 2015. And the scientific community got really excited because basically they found this star that was doing something that we had never seen before. It has these insane dips in the brightness of the star. So the Kepler Space Telescope basically was, in space, and it was looking at a patch of sky for 4 years, and it was basically monitoring the brightness of the stars over time. And so if you just make on a graph how bright a star is as a function of time, well, it produces what we call a light curve. And so the light curve of the Tabby star was doing these insanely bizarre things. And so the astronomy community was like, well, this is it. This is our golden shot. Like this is something that we can't explain. So is it aliens? Probably not. I think that there's been a lot of sophisticated sort of analysis on this, and so they've shown that this is some other physical mechanism that's happening that's obscuring the light. But this is just one example of like what this could possibly look like. That what we call in the field anomaly detection. So anything that looks weird is interesting. So there's a whole field of research of people looking for weird things in space, which is always fun to hear.
Yeah, that's coming back to the point. If you guys want to go and check it out, Rod Stubbings, that's interview 50, where I had a guy, we talked about variable star observations, and that's what we're talking about. So this man is, again, the amount of work that he added, and he's, runs his company. He's like a full-time plumber business type of thing. He's in Australia. Wow. And he has, his own built, observatory at home. Again, I'm sure like having a lot of clear skies is probably not that big of a problem in Australia in some parts. And again, this man is, with this 22-inch Dobsonian telescope, he did so much observation. I think he's a third right now. I'm sure soon going to be the second in the world when it comes to, I think he did 300,000 variable star observations.
Wow.
So we're talking about a lot of time and hours and work, dedicated to providing again and watching variable stars and seeing if there is difference in that and determining what makes that change in those stars and these objects. So, I mean, I love the fact that, again, as you mentioned, more people are getting exposed to what's happening. And now, again, besides having, observatories or space agencies being part of that, there's day-to-day people adding value to to the science in general.
Absolutely. Amateur astronomers are really driving a huge part of the discovery in astronomy. Specifically what I work here at California, we do rely, well, I should say that, we do rely a lot about how amateur astronomers could do their follow-ups. And there's whole research organizations that basically organize them, and that way we can get the data, and then we who work in universities usually have access to bigger telescopes. So we collaborate with amateur astronomers to basically figure out what's interesting, what's not interesting, because it really gives us an international eye on the sky. So, for example, okay, right now I'm located in New York, and let's say I found something in last night's data, but I want to go on the sky right now. I could maybe say an amateur astronomer who's located in China or in India, and I could say, hey, I need a picture of this part of the sky. Can you grab it for me? So that's just has opened up a whole new area, an era of just doing astronomy, an international sort of perspective.
Exactly. If you don't mind me coming back to the part where we talked about this kind of uncovering if there is a chance of having extraterrestrial life forms, and kind of coming back to the Carl Sagan part, the entire kind of golden disc that's been or put on Voyager. It's a beautiful thing that we as people did. It's again it's poetic, it's artistic, and again I love the fact putting let's say our location that were placed in the galaxy, and again the DNA, and putting the music in again that whole entire idea. As I remember watching it, I don't remember exactly who said that if these life forms will uncover that, they will be able to read the data, because it's again it's in science, it's in math. So do you believe, again, and I was questioning that, if there was life forms, again, if we're talking about more advanced, less advanced, but let's say in this case more advanced, why do we think that that life form, as you mentioned, can project, with kind of X-ray or just different, different types of, information that they can share? Why it should be that the math is a universal language? Maybe it could be something else, and maybe the way we're looking at the universe, applying the math and the physics, is probably in the way of actually for us discovering the answers of the universe.
Yeah, that's a good question. Yeah, I've heard this question a lot about like, is physics and math really a biased sort of perspective? Is it sort of a human intervention? I think that there's a paradox to that, and the problem with that is that science works. and that's really one of the really strong things that we know about science, and that, like, well, you could say, like, for example, yeah, like 1 + 1 is 2, but like, right, we invented this notion of counting. But if you go from the simple concept of 1 + 1, and from 1 + 1 to airplanes flying, for example, well, airplanes are in the freaking air, right? Like, I mean, like, you don't see airplanes just falling out of the sky, because science works. We have such science is really such a powerful tool, because we realize that, right, from an external perspective of, like, maybe someone who, some person who's just not into science might say, well, yeah, aren't scientists like biased, or like, don't they just make these things up? Well, sure, it might seem like we're making things up, but what science really is just a huge cookbook of what we have noticed about the world. So, for example, if I take my bottle of water, well, I guess you can't see it, but if I pick up something and I drop it, it falls down to the ground, and that's an observation, right? So you go from something that's happening to right. Of course, humans have this notion of going a little more abstract than just simple observations, but we know that things happen in nature, and what the goal is to sort of explain them. It doesn't matter if you're using 1 + 1. It doesn't matter if you're using A + A. It doesn't matter what you're using it, but what we do know is that it happens. So, for example, the speed of light. We know that the speed of light, no matter how you calculate it, it is the speed of the light. It doesn't matter if it's the speed of the light in apples. It doesn't matter if it's in meters per second. But what is true is that it has a value. It has an estimate. It's a fixed constant. So what astronomers go off of the assumption is that the universe has the same laws of physics and nature, the same laws of nature in every part of the universe. So if you're an intelligent civilization that's like 100 light years away from Earth, for example, the same laws of physics are applying there too. So if you were a caveman, you have cave people who are just starting out life, let's say on some remote planet, it seems likely that there are just certain things. They would probably notice that there's gravity on their planet too, because we know that an object with mass has its own gravitational field, and things fall to its surface. So it is very likely that we can say that they would reach the same conclusions that we would. It doesn't need to be the same language, but it would, in essence, it would reach the same sort of conclusion that light has a finite speed, or things fall to the surface of an object that has mass. And so the golden record that's on the Voyager goes off of that assumption that we would perhaps arrive to the same points of conclusion. And some civilizations might be at like points where we don't even know, we wouldn't even imagine where they're at. I mean, they might make discoveries that we can't even imagine. So it goes also beyond that, but it also goes before that too. I mean, you might have civilizations who are still living in their caves, because it might just be a probabilistic fluke, meaning that they might not just understand that you could pick up a rock and make a tool. So it really encapsulates a huge range of possibilities and things of how this comes to be.
Exactly. So if you just said science works, that probably would be a great answer.
Yeah.
You can kind of wrap it up right there. It definitely works, but what about the pieces that we still didn't figure it out yet? We're talking about the black holes that, again, the science and the physics, probably the laws that we have here don't apply there. What about the multiverse, and what, are you following, these kind of subjects as well? What do you think about the entire theory of multiverse and something, happening? Let's say we're having this conversation and there's something else exactly the same, probably with some time delay, or something happening or happened before in a different part of the universe. What do you think?
Yeah. I think that, so I don't follow specifically sort of what's the latest research on it. But I could tell you that sort of from my perspective, I see it also within my field, right? There's always going to be subjects in science that are pushing the boundary of our understanding. So an idea of a multiverse, I'm very open to it. I think a lot of the scientific community is open to it. What we do need, though, is the foundation of science of how it works here on Earth is through observation. So I think that the next sort of generation of how we will be able to make this more of a reality, or more of like a concrete scientific fact, is through ways of how we could possibly make this into an experiment. I mean, when you think about like what work is being done at CERN, for example, right? Like we're crashing particles that we can't even see, right? And if you went 200, 300 years before that, and you told some ancient, scientist that's something, they would say, you have to be kidding me, right? Like that's not a real thing. So I always say that governments should always encourage scientists to just follow their crazy ideas, because you don't know what's going to be the next breakthrough in science. Indeed. So yeah, totally possible. I could totally see it happening. Awesome. But we need the observational signatures. I think that's one key thing that is missing still.
Yeah, so talking again about those observational signatures, why is it for you important? And maybe you can give us a little bit more information about observing, stars before they go supernova. Yeah. I mean, what type of information you can pull from these events, and why do we observe these events happening?
Right. So right now I'm working at Caltech under an optical survey telescope. So it's called the Zwicky Transient Facility Survey. So this is a 48-inch telescope located at Palomar Observatory in California, and it was launched in 2017. So so it's called the ZTF survey, and basically what we do is that we every night take pictures of the night sky in California, and basically what it does, it tries to take pictures of the entire night sky. To give you an example of how amazing this telescope is and how amazing this camera is. It's 47 square degrees of field of view. So one picture taken from the ZTF survey covers 235 full moons times it's 235 times the area of a full moon. So this is extremely wide. So what it really is, it really gives you an amazingly good perspective of what's happening at the night sky every night. And so what we do is we take two images, let's say one night before and one night tonight, and we basically subtract these images. And if you were to assume that nothing had changed in the universe, basically you would get 0 because 2 identical pictures, right, would just cancel out to be nothing. But what changes is the interesting part. So if a star in some other galaxy went supernova, then suddenly you would see a little dot. You would see a little dot in your data, and you would say, well, what is that? Like, how did that dot come to be? So this was sort of how, this is sort of the science of how it was built. So basically with ZTF, we are studying what we call the time domain astronomy. So we're studying things that are constantly changing in brightness every night. And so using these telescopes, we could study the change in light over time. So this is how things are getting brighter or dimmer over time. So yeah, we have a whole, I mean, the survey, we study a lot of things. We study supernova, we study variable stars, we study galaxies, all sorts of amazing things.
Mm-hmm. So part of that work is just pulling the data and gathering the data to find out how the galaxies were formed, right?
Yeah. Well, astronomy is really reaching a point now where we are becoming more smart of how this is happening. So these telescopes are robotic. So there's not even anyone at the observatory. We literally, like, you press a button and, there's all these sort of built-in algorithms that know exactly what to do. Take the pictures, and then every night we get a batch of data, and yeah, we start doing science. So it's very convenient not having to stay up every night.
So what do you think again? So I do imagine the way I mean, it's probably a lot of people listening or watching to what you're saying right now, and they're like, oh my God, I would love to do that. And again, if you just rewind back to the beginning of the conversation, he will tell you how to follow that path if you're following to be an astrophysicist. So we can do the same. So the question is again, because my favorite quote, one of the favorite quotes is, the best math that we can learn is how to calculate the future cost of our current decisions.
Yeah.
Because it is, again, the fact, as you mentioned, that, making certain decisions in life, for people, it is kind of the main piece. I think that if people would know this quote, I think they will choose their decisions more carefully, because anything that you improve or do negative in here, it will affect your future, going further. Of course, you can change the trajectory going further, but it's a lot of work. So you want to make more great choices. So what do you think about making a lot of these different choices in science and communication instead of letting humans to make decisions, using, as you said, more of a kind of AI-based technology to make a lot of those decisions, which I know, and a lot of those decisions being used, again, I'm sure NASA, ESA is using that into, astronaut training and picking which astronaut is going to be next.
Right.
Actually, that's AI technology who is picking those future commercial astronauts and even in more, again, and just, in a day-to-day basis, in the technologies that we have in at home. So do you feel like AI could be a great, our friend going along in the future and help us to make more great quality decisions? Or it could be a potential kind of thing as a risk for us?
Yeah, I think that this is a quite controversial thing. I think that there's 2 schools of thoughts, right? There's the school of thought that AI is bad and it's going to take over the world, which is I think Stephen Hawking had said this, maybe. Did he say this? Maybe. I don't know, maybe he didn't. But someone had said that, one of the greatest dangers to society is going to be AI. And I think that that's true, but in a way that it's not as obvious. So one of the foundations about AI is what we call the training data set. So basically, if you have a computer, right, and you were to say, make some predictions about the stock, right? What the foundation of that sort of the traditional algorithms is that you give it a training set. So you basically tell it, well, this is what sort of the previous examples look like, and now I want you to make predictions for the future. But the problem with that is that what do you give it for a training, for example, right? Like what is the prior information that we give it to make predictions about the future? So I think that we need to be really cautious in how we use AI and really start to think about our own bias.
Because we control the input, right?
Exactly, we control the input, but the input is more dangerous than the output. Because if, for example, so here's a recent example. Okay, so if you have, let's say, some universities now are using AI to screen applications for medical students. And this is, of course, a great technology when you have thousands of applications to read. But the question is, well, what do they want the AI algorithm to look for? If it's, for example, some student who went to Harvard and had a 4.0 GPA without taking that human component into it, that, like maybe I had worse grades, but, I have a sort of a more human story, right? Like, if the input is really trained on learning that other side of the sort of more like traditional scientific path, then your results are biased. So in AI, we really need to think very carefully of what we're training our machines to do, to give us the least biased perspective as possible.
Well, I'm sure there will be a lot of room for error. Part of that is going to be just like with with innovation, whatever we do, and in the industry, there's always room to improve. And I think part of that is going to be with AI, is looking for ways how to make an input of making more of a kind of human-like decision based on probably certain characteristics, which I'm sure AI can determine by just looks of the photo, probably can extract certain, or just by seeing the video of person talking for 10 seconds, probably can extract the values of the person and things like that. So because it's pretty smart technology as far as I'm seeing. So.
Yeah, I mean, the one thing I think, I'm not sure if this is entirely true, but I think that in robotics, for example, there's a whole sector of trying to make robots and AI more human. And humans are really complicated because, I mean, like we have emotion, we have all of these sort of neurological phenomena happening within us. So it's really hard to teach a machine to do that. So, but if we can, I mean, that would be amazing because, well, it would be amazing, right? We would want to make machines that are like humans, but don't make the mistakes that humans make, because humans are inherently very biased and have, unfortunately, many flaws that can translate into our science, into our policies, into a lot of things. So we want to create a human, but minus all the flaws.
So how do you see, I mean, AI or machine learning like benefiting the science? And maybe you can give a few examples. How is that being applied currently in your personal research?
Yeah. So we use for the ZTF survey, we use machine learning every day. So we have an algorithm that basically tells us, when we subtract the two images, it gives us a score on how good that subtraction was, for example. And that could really give us an idea of the false positives. So for example, something in the night sky might have changed, but that might just be some noise in the data. For example, machine learning could be used to let's see, learn or discover, for example, a comet. So recently within our group, someone discovered a comet using AI. So basically, you feed it a bunch of pictures and there's a model and it does all these sort of sophisticated things to basically tell us, oh yeah, like look at this thing. This is a comet, or this is the chance that this is a comet. So in specifically in the field of time domain astronomy, AI is becoming the next hot topic. So yeah, it's increasingly its popularity. One thing that I think that's quite interesting in sort of the astrophysics community is that there's a little bit of hesitancy about it because it's so new. So when you have scientists who are, that were scientists in, let's say, the 90s, well, they didn't even have half of the technology that we have today. So unfortunately, there's a big body of scientists who are just skeptical about the tool. So I think we're seeing it more from the younger researchers who are more eager to apply these sort of new innovative technologies to make discoveries in astronomy. But I think that the field as a whole, where everyone's moving towards a direction of machine learning and using sort of a more automated way of making discoveries in the least sort of biased as possible.
Yeah, well, I do understand where these scientists are coming
Yeah,
from. Like,
yeah,
probably majority of them, they're saying that, like, look, I don't need the machine to tell me.
yeah.
Like, I have my PhD and master degrees and things like that. Like,
Yeah,
I've been in this thing for 20, 30 years, and I know my thing. I
right.
know how to spot. I have an eye on everything. Believe me, that's what
Yeah,
they say. Part of that is because they're scared, because they know that AI is the technology that can make innovations in a time of what a person can do in 30 years probably can do in a few minutes or a few hours.
exactly. Yeah.
And it can go beyond that really fast. So those people saying that because they probably know what's coming, or a lot of them, they just keeping their kind of mind shut off from that idea that this is going to be the future.
Yeah, yeah, yeah. I think that the first point you made is definitely very true. That it is possible that some people feel threatened by it, but I think that the very interesting thing is going to be that, especially if you want to go into sort of what I'm doing right now, observational astronomy.
Mhm.
I mean, the direction all arrows are pointing towards, sort of big data analytics, because when you want to study, let's say discover supernova, for example. Let's say you want to do this how they used to do it in back in the old days, right? Like in the 80s or in the 90s, right? What you would have to do is take pictures and go by eye, right? And you would have to like look at two images and compare. So you know how Clyde Tombaugh in the 1930s discovered Pluto, right? He had two images and like looked at them, right? Imagine doing that for millions and trillions of pictures every night,
Yeah.
not every year, night. So all arrows, all points of direction are pointing towards that. We need to learn how to handle huge amounts of data, because that's the only way that we're going to be making discoveries in this age. We need intelligent technology. We need innovative tools to catch up to our times. That's why you see Facebook and Google and all these big corporations doing these really big decisions, because they caught on that train really early. They're like, yeah, like physics, math, data science, give it to me, because this is a golden pot for us to come and really make leverage our platform. So
Data is
yeah,
everything.
data is everything. It really is, and it's
Yeah.
it's it's honestly exciting when you look at it. When you really take a step back and you realize it, it honestly can give us a lot of insights to a lot of key questions.
And especially for a person like you who is data driven and you all about numbers and give me the stats, that is awesome. That is
Yeah.
definitely awesome, because I do believe it will give us a lot of benefits, because I wouldn't personally, just for the sake of innovation and again just for the fact of us being multiplanetary species,
Yeah.
I would love some sort of it's either different input that we need in our educational system or something that will be kind of from extraterrestrial somewhere. It's
Right.
either that or we need to create a technology that will help us to make better decisions so we can propel us faster in the future and have those scenarios
Absolutely.
faster.
Absolutely.
What do,
Absolutely.
what do you think about the case again of one of the kind of leading people in the space industry, like Elon Musk, talking about our brain merging with AI and creating kind of this symbiotic relationship? Would you go for it, against it?
um, yeah, I mean, I think again, it's like one of those things where I think that Elon Musk is I don't really have like any objection on him. I think that he is a thinker in our time that's really trying to think beyond. He's really
Hmm.
pushing the boundary of our understanding. I mean, when you look at SpaceX, for example, of course, SpaceX is doing incredible things. It really, really, it just the time scale of what SpaceX's success has been is really just astonishing. Um, so I think that Elon Musk is really just trying to push the boundary of human understanding. Whether that's going to be a successful thing or not, I think time is going to dictate that. Like emerging like humans with AI chips and all these sort of things. Well, yeah, I think it's sort of the same analogy of flying cars. Like back in the 90s when everyone was talking about flying cars, they would say, "Oh yeah, by like the early 2000s we would have flying cars." And I mean, like I'm looking outside the street right now and I don't see no flying cars. In fact, I see more cars than I would see flying cars.
Well, there is
I
a flying car, but people don't look at it as a flying car. It's called a plane.
A plane, yeah, exactly. So I think that that is a similar analogy to that. That it could be very promising. I mean, yeah, like I don't know, like I don't know what the details are, but what I could say is that like time will dictate if this is sort of if this is an actual path. But one thing that we need to again be very cautious about now that we're entering this amazing era of science and technology. You know how we were talking about in the beginning about accessibility of science.
Hmm.
Once we give, so this is a quote by I believe I don't remember who said this quote, but essentially that science is like science is a key to a door, but no one tells us what's on the other side of this door. It doesn't come with instructions on how to use it. So what I'm worried about is that sometimes we're going to be too fast in using our technology, and we're not going to think critically and carefully about what is this technology really going to do to us. And this is not to say that Elon Musk is a conspiracy theorist and he's going to try to control the world. This is just a simple thing of just saying that whatever technology that we're proposing to society, whether that's an electric car, a flying car, whatever it is, we need to have an official way of saying, this is a danger to society, because we have just in the history of humanity, we've seen too many of these mistakes where we have had humans have had these breakthrough ideas, and they're going to change the world, but they actually ended up being very devastating, killing people, making people very objective, doing all sorts of psychological effects. So I think that we should be critical. It's okay to read about it and fantasize it about it, but I think that as any citizen should, is to think carefully, take all facts into consideration, and really ask, like, is this for the better of humanity or for the worse of humanity?
For sure, because exactly, we made a lot of these mistakes, as you said, and part of these mistakes is, again, I had one of the guests, Jonathan Federworm. I just found that again by
Mhm.
scrolling here quickly on the file, and he put together this episode 54 for somebody who wants to check it out. He has a graphic novel. It's called Trinity: A Graphic
Mhm.
History of the First Atomic Bomb. So because his grandfather, he used to work on this project. It's called Manhattan Project. It was
Yeah.
kind of, yeah. So, and we kind of talked about that, and us as people making, again, it was a big innovation that kind of propelled us in different sectors. And now we have a propulsion system that is based on nuclear power also, and we're
Yeah.
working on that. And I mean, it benefits a lot of the things, like, but the damage is certainly was there also.
Right. It
So.
doesn't come. It doesn't come with instructions. So
Yeah.
I'm worried sometimes that it's like the internet, right? Like, I mean, the internet has amazing things, it has bad things.
Yep.
No one tells us how. There was no book written to how to use these technologies. So I think a part of that is that we as humans need to be more careful on how we use it.
So what do you think overall scenario will be for the planet? I mean, are you optimistic? You're pessimistic? I mean, looking and that you're a more kind of data-driven guy.
Yeah.
Maybe you can give us some insights, like what's heading, in front of us. Like, is this going to be kind of great future for us, as species? We're going to have some advanced technology. Life is going to be great. Or, in a billion years, the sun is going to burn the oceans. We're going to go down that way, and it's going to be over for us. Like,
Yeah.
what do you
Yeah.
personally see is going to happen?
So I was recently talking to someone about this, and I'm optimistic because I think I'm an optimist just to start with. But I think that, and this is, when I talk to people about, like, why should we pay people our tax money to have astronomers and astrophysicists? Um, here's my sort of personal theory. I think that if in our lifetimes we had found intelligent civilization, okay, let's say we found some sort of life form 100 light years from now, this would prove the fact that intelligent life is capable of going beyond of what we have right now. So I think that humans as a whole right now we're being tested. We have all these pressing problems. We have a pandemic. We have a racial pandemic. We have global warming that's becoming a thing. Nations are divided, or war, famine, all of these terrible things that when you look at the data, you're like, the projection doesn't look good. It looks like we're not going to even make it. Like it really looks like humanity's story is going to be cut short, because we don't know if this is sort of in our nature. It's like maybe like an Olympic athlete that, if you're an Olympic athlete, when you're a child, you didn't know that you could lift, I don't know, like 300 pounds or whatever, right? But it's only when you reach to that point, you're like, yeah, I could do it, right? Like, so we don't have an example to say like, yeah, there's some civilization that's way beyond the technology of Earth that makes it possible for us to know that we can make it that far. So once we are able to maybe say, well, hold on, there is life in the universe, there is life that is more advanced than we are, then that means that we are able to get beyond this. But right now, Earth, society, humanity is the only example that we have in our data. It's one data point where we know life, intelligent life is a thing. We know that, but we don't know if it's sustainable. A very grim approach to it would be, well, it might just be the fact that all intelligent life sort of destroys itself, because intelligent life inherently is very dangerous. Some people might say that. Some other people might say, well, if we discover some other civilization that has superior technology and is shown that we can get through these stages of humanity safely, then it is possible. It is possible that, we could, colonize Mars, not colonize, but we could go to Mars. I don't like that word, but, go to Mars. It's really not colonization. It's really just expanding our horizons. It's just really just thinking about it more in a cosmic perspective.
Exactly. So I do agree with you. I mean, first of all, in colonization part, I don't think it's a good word to use.
It's really not.
Yeah. Second of all, I guess, as I mentioned, not having an example of other planets that would be, lived by, some sort of a species, and they can give us an example of what's possible for us as humans with this planet. I think we have, at least when it comes to example, we have a lot of Steven Spielberg movies and, a big dream ahead of us, which I think, because humans, just the fact that we can persevere, because again, we, came through a lot of stuff. And again, the problems that we created is, I mean, we did created all the wars, we did created everything. I mean, the Earth, nothing else, no meteor created nothing unless it's that. And that was, millions of years ago for the dinosaurs, but unless it's this type of scenario and the rest of what we have going on, everything has been created by us, all the problems that we're having.
Exactly.
So, but, hopefully, again, the dream, because the dream keeps us alive, and, having this vision for the future as us, making either breaking through, science kind of findings, if it's, again, looking at the supernova and seeing how the galaxies form, or looking for, different life forms and looking for ways that we can travel to these planets and maybe make them habitable. So it starts with one step at a time, because look, we haven't been on this planet for really that long,
Really not that long at all. Yeah.
So there's a lot of kind of bright future, and I see again with people just like yourself who are being part of that change, which I think the biggest problem as far as having these episodes is now at 72. With all the different people just like you involved in space science, engineers from NASA, and asking similar sometimes questions, you find out that it's not the technology, which of course is a big problem, how to travel and the light speed and all these millions of light years away, but it's having this universal thinking where that's where the change starts.
The universal thinking.
Having universal thinking instead of having this Earth-like thinking about it's the new Apple computer, I need that. It's the new iPhone, the Gucci shoes, all the stuff that basically doesn't matter when you think about that. It's having this universal thinking and then thinking about, because if you're going to look at a typical scientist, if you can picture that, you're not going to see him wearing Gucci shoes because he doesn't think
No,
about that,
no,
right?
of course, and right, and I mean, of course, you occasionally you'll meet people who want
Yeah.
to portray that sort of view, but right, it's a much more simple idea, and I think that science is more human than what we think it is, you know, and I think
Yep.
it's more human than what society portrays it, right? Like scientists are these evil genius, like Frankenstein, right? Like just like these evil geniuses who just have these crazy ideas. Well, no, not really. I mean, it's really at the end of the day, we're just trying to shed some understanding and really trying to humanize our place in the universe. You know, I think astronomy, especially, is such a humbling field because it really makes you think. It really makes you think about, well, the meaning that we create is it's the ones that we create within our own community. It's how we are kind to each other. It's how it's all related to our actions. So I think that astronomy, you know, one of the biggest lessons for me is that like um, the change doesn't come from technology, as you said. The change comes from the people. The change comes from our ideas and how we communicate with each other and how we care about other people. So at the end of the day, I always tell people that it's more important for you to be a human than it is to be a scientist, because science is just a school of thought. But you, at the end of the day, you need to be compassionate. You need to be a human to sort of, you know, live your life, you know, in a very fulfilling way.
Exactly, exactly. So, and I think, you know, overall, we as people, we're just naturally explorers. We do like exploring things and stuff and traveling places and, you know, seeing things and just having that experience of life. Because at the end of the day, like, you know, making money, like in what you do or what I do, what other people who watch, you know, if you enjoy what you do, that is awesome. If you can, you know, add value to the society and make money at the same time, that is beautiful.
Right.
But at the end of the day, when we gonna leave the planet, we're just gonna remember again before that, we're gonna remember all the life experiences that we had and collected
Exactly.
through that time.
Exactly.
So
Exactly.
again, coming back to kind of this kind of human part instead of chasing, you know, the because I think there's a lot of people who are making a positive input in our society, and one of those is again being Elon Musk and other people who you don't see on social media. They're working a lot kind of behind the scenes, as the guy that I mentioned, you know, in Australia. Nobody
Yeah.
knows about him, but he makes
Yeah.
a lot of, you know, adds to the science in general.
Yeah.
Or there's people again, just, you know, as you mentioned, you know, Facebook or Google. I think it could be a lot of it as a probably negative input. Because I think a lot of it, what's happening right now, you know, with people having these different perspectives and ideas and thoughts, and a lot of it is being, the information is being distorted, which is a big problem. So
Oh, huge problem. Yeah.
it is a huge problem. So, and that's why I'm super happy, like every time to talk to somebody with just like you who have inside information, because you're working, you know, in these projects, and
Yeah.
again, you're seeing what's happening, and it just, you know, brings more kind of again more happiness and more joy, and brings back to the moment of, you know, we need to think, you know, we need to dream bigger and know that the future is really going to be bright. So, you know, I
Absolutely.
just want to say huge thank you again for what you do, for putting all this work, which I know it's not always easy.
Thank you.
Probably, you know, you have some tough times, as we all people do, but you just continue to persevere, and I hope you know, you're going to continue to be that way, and you're going to continue to innovate and, you know, put more great things in front of us, information, data. We're looking for that. So, what would you say, Andy, yourself? I mean, how would you close this interview? What would you say for the people who are kind of coming on this type of interview for the first time? They never heard some people talking about space and exploring and data and science. What would you say for them?
That's a I think that if there's one thing that I could take away from this conversation, and sort of to summarize everything, is that um, we're really at an early stage in how we still perceive science, even though science has been happening in humanity for a really long time. I think that we're at the brink of this new era of how we understand science, and science specifically in the role of society, right? You talk about astronomy, which is such a, you know, a literally out of this world sort of field of study. But um, what 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 I think is the biggest lesson for me is that the most unexpected uh, walks, if you want to say, right? Like as we started this episode talking about like a walk to a supermarket or a walk to a park. These sort of journeys in life are the most beautiful thing. So I always tell people, don't be afraid to explore something, whether that's your passion for anything, for cooking, for whatever it is, because you just don't know what you're going to discover on the other side of your journey. And especially when you have like a journey with a goal in mind, there's so much that you can learn. So I think that science is like that we're on a journey, and right now we're I don't know what point we're at, but we are just learning so much about it. And so I always tell people that just follow your passion, and science is we're really entering this amazingly exciting era of science and science communication. So people should just be excited, and people should be eager to learn, because these perspectives of what we can learn from science is life-changing. It's almost like a lifestyle. It's when you start to read about the Earth, when you start to read about chemistry and physics and astronomy, your life changes, because something goes off in your mind. You're like, hold on a second, like the world is a lot more beautiful than what society portrays it, and there's like this innate beauty in it. So I think that's the untapped potential that people really need that medicine.
Beautiful, beautiful. That's a great way to close it right there. So, guys and girls, as always, last thing that I wanted to ask you, again, if you share this episode, I mean, it's been a really awesome interview here with Andy. I mean, going across the board of different topics, but I mean, a lot of like all these topics is super important, because I mean, the future is now. So if you just share this episode with your friend and open their mind a little bit to the, first of all, to what's happening in astrophysics and in astronomy and science and in general, what's happened with the data science, and again open their personal mind for the future opportunities that they can join the ranks of astrophysicists. I mean, there's so many different businesses, software, data, businesses are being created these days. I mean, it's insane during the pandemic. So look, the opportunities are out there. So I do encourage you guys and girls take part of it. If it's again through astrophotography, getting involved again in astrophysics, astronomy in any way possible, because we need more people just like Andy, again, who putting his time and work and effort, I mean, into making this happen, to find groundbreaking research so we can just continue to expand as species, live happily, have all the answers that we need. And it's a beautiful thing. So again, guys, thank you for watching this episode, and as always, I'll see you next time, and until then, don't forget to keep exploring.
Thank you.